This video is about solving two-step equations. By the end of this video, you should be able to say, I can solve two-step equations, and I can identify the properties of equality. So these are the two things you need to be able to do by the end. Vocabulary would be properties and two-step equations. So starting on page 121, we're going to look at the properties of equality. And so properties are statements that are true for any number. So we're going to take a look at the addition property of equality, and much like it sounds, it deals with addition, and it says that you can add anything you want to an equation as long as you do the same thing to both sides. So the example of that would be down here on the bottom, where they're showing that they're adding plus 5 to each side of the equation. Taking a look for the division property, it says we can divide any number, an equation by any number, as long as we do the same thing to both sides. And that would be right across here, where they're showing the division, dividing both sides by 3. The multiplication property says we can multiply by anything we'd like, as long as we multiply the same thing, we do the same thing to both sides. So here we have times 2. Times 2, there's your multiplication property, and of course the subtraction property says the same thing for subtraction. So here's where we have minus 3, minus 3. They're showing what they did that they did the same thing to both sides. So those are the 4 major properties of equality. Those are the things that you have to do. We have to do the same thing to both sides in order to preserve the equality. So turning to page 122, we see at the top here our next vocabulary term, and that would be two-step equations. Two-step equations contain two operations. And so, like for instance, this equation here, 2x plus 3 equals 7, it contains multiplication and addition. In order to solve two-step equations, we need to undo the operations in the opposite order that we would do them in, and we'll talk about that more in a second. Example number 1 on page 122 shows you a pictorial method or an actual physical method of solving equations. So if you're interested in learning more about that, just ask me and I'll show you how to do that. We're going to concentrate, however, more so on method 2 that they show you on page 122, and that's the actual algebraic method of solving. Again, as with every equation, the goal of solving an equation is to isolate the variable. Whatever we do to one side, we must do to the other, and we just talked about those properties. And to solve an equation is to undo it. And here's where it becomes even more important to think of that. So when we're solving an equation, we're going to undo the operations that they have backwards from the order of operations. So whereas we would, when we're evaluating, we would do parentheses, exponents, multiplication, division, then addition and subtraction last, we're going to undo the addition and subtraction first, then we're going to undo the multiplication and division. So still on page 122, they give you method 2, which is the algebraic method of solving. Notice, to get rid of plus 3, they subtract 3 from both sides, just like we've been doing. And to get rid of times 2, they divide both sides of the equal sign by 2, just like we've been doing. So these are like our one-step equations, except they're kind of pushed together into the same equation. So we have two different equations mixed, kind of. So taking a look at, I'm going to skip the got it A because that one's fairly simple and B is a little bit more complicated. So taking a look here at got it B, again, still on page 122, we need n by itself. And so in order to get n by itself, we need to get rid of plus 5, because 5 is positive, so that means it's added, it's not being multiplied or divided, and then times 2. In order to get rid of those, we're going to undo the plus first. So I'm going to subtract 5 from both sides of the equation. When I do that, the 5's cancel, and I'm left with 2n equals negative 6. Be careful of those negative signs. Now I need to get rid of times 2, so I'm going to divide both sides by 2. If I divide one side by 2, I have to divide both sides by 2. Now the 2's cancel each other and become 1, careful not 0, and I'm left with n equals negative 6 divided by 2 is negative 3. N is by itself, and so I've solved the equation. The variable's isolated, I've reached my goal. To check this, I would substitute in. So over here, I'm just going to quickly check it. So 5 plus 2 times negative 3 equals negative 1. Is that true? If that's what I want to know. So we have 2 times negative 3 is negative 6. 5 plus negative 6 is negative 1. I'm good. Taking a look at page 123, at the top here, example 2, at the top in example 2, you notice they have an equation that's got subtraction and multiplying by a rational coefficient. So this is like the equations. The rational coefficient part is like the equations we were doing yesterday. So I'm going to do both of these. I'm just going to rewrite it. So got it C, I have negative 1 equals 1/2 A plus 9. And so I need to get rid of times 1/2 and plus 9. I'm going to follow the order of operations backwards to undo the equation, so I'm going to subtract 9 from both sides. So when I do that, I get negative 10, because remember, keep, change. So I get negative 10 on the left side equals 1/2 times A. Now, A is not by itself, so I need to keep going. So now I need to get rid of times 1/2. So remember that to get rid of multiplying by a fraction, we can multiply by its reciprocal. So I'm going to multiply both sides of this equation by 2. And I'm not going to write 2 over 1 on the left side because it's not a fraction. So I have 2 times negative 10 gives me negative 20. The 2 and the 1/2 cancel each other out, so I have A equals negative 20. To check that, I would substitute in. So half of negative 20 is negative 10, plus 9 is negative 1, so I'm good. Taking a look at got it D, so I have 2/5 R minus 5 equals 7. I need to get rid of times 2/5 and minus 5, so I'm going to get rid of the minus 5 first by adding 5 to both sides. So I have 2/5 R equals 12, because the 5's are going to cancel each other out. Now to get rid of times 2/5, I could divide by 2/5, but every time I divide by a fraction, I multiply by the reciprocal, so I'm going to multiply by 5/2. If I do that to one side, I have to do that to both sides. Now, because I'm multiplying by a fraction, I'm just going to write the 12 over 1. So the 5/2 and the 2/5 cancel each other out. I'm left with R equals, and over here on the right side of the equation, I'm going to cancel the 12 and the 2. 2 goes into 2 one time, goes into 12 6 times, so I end up with R equals 30. To check that, I substituted into my original equation 2/3 of 30, 2/5 of 30. So 30 divided by 5 is 6, times 2 is 12, 12 minus 5 is 7, so I'm correct. Still on page 123. Example 3 has a nice example of how to solve it. We're going to take a look at the bottom at the got it's though. So again, in the interest of time, we're just going to concentrate on a couple of these got it's. We're going to do got it E and got it G because those are the more complicated of the ones. So we're going to take a look here. I have 10 minus 2/3 P equals 52. So I need to get rid of plus 10 because in front of the 10 it's positive, so that means I need to get rid of plus 10 and times negative 2/3. So I'm going to get rid of plus 10 first by subtracting 10 from both sides. So I get negative 2/3 P equals 42. And so now I need to get rid of times negative 2/3. I'm going to multiply by the reciprocal. So I'm going to multiply by negative 3/2, both sides. I'm going to write the 42 over 1 just to keep fractions the same. Over on the left side of the equal sign, that's the easy part. Those multiplicative inverses cancel each other out. So now I have P equals, and I'm going to cross simplify here. 2 goes into 2 one time, it goes into 42 21 times. So 21 times 3 is negative 61. To check that, of course, I'd substitute it back into my original equation to see if I have a true statement. Got it? G, I have n divided by negative 3 minus 2 equals negative 18. So I need to get rid of I need to get rid of divided by negative 3 and minus 2. I'm going to get rid of the subtraction first by adding 2 to both sides of the equal sign. So I get n divided by negative 3 equals negative 16. Now I need to get rid of times negative 3, divide by negative 3, so I'm going to multiply by negative 3. And so on the left side, the 3's cancel. I'm left with n equals. On the right side, I have negative 16 times negative 3 is going to be positive 48. And to check that, of course, I'd substitute back into my original equation. So we have 48 divided by 3 is going to be, divided by negative 3 is going to be negative 16, minus another 2 is negative 18. So we're good. And last but not least, on page 124 at the top, there's another example they give you. This one is where they're actually using a formula, the formula to find Fahrenheit when you have, Celsius when you have the Fahrenheit temperature. So they substitute in, it says Chicago's lowest recorded temperature in degrees Fahrenheit is negative 27 degrees. Solve the equation negative 27 equals 1.8 C plus 32 to convert the degrees to Celsius. So what you're going to do is they put in the Fahrenheit, the negative 27 for F, and you're going to solve the equation, and you get negative 32 and 8/10 degrees Celsius. So keep in mind, when you're solving two-step equations, you still need to have the 3 main guiding principles. The goal of solving an equation is to isolate the variable. You can do whatever you want to you can do whatever you want to an equation as long as you do the same thing to both sides. And we're to solve an equation, we're undoing it, and we're going to work the order of operations backwards when there's more than one operation to undo. Good luck and have fun.